Right, let's jump into it. I'm giddy. This is gonna be fun. There's a severe thunderstorm outside. I'm terrified. You're not terrified. It's probably nice and peaceful where you're at, but yeah, let's do this. So basically, what you'll need is Xcode, and you'll also need GitHub Desktop. And what those look like is this. Just go online, find Xcode, download it. It basically comes with everything you need. It's not like a C++ OpenGL application where you need to get all these different libraries. It's very simple. Just open Xcode and it works. That's why I love this. And then the GitHub Desktop, that's going to be for our Git. Instead of doing commands and stuff, I can just show you the diffs if I wanted to. It makes it really simple. I'm not going to do super branching, and it's good. It's free, which is nice, and there's not ads everywhere. I hate ads. So yeah, basically what we're going to do is let's get started. I think we're ready. Are you ready? Yeah. So first thing we'll do, open up Xcode. And there it is. Okay, so we're going to want to create an Xcode project. And since we're going to make a desktop application because, well, it's awesome, and I'll show you why. If you go to Apple has this developer Metal right here. This site right here will take you to all these beautiful references. We have Metal best practices, programming, all of these are good. They have the WWDC videos, which these are super informative. If you ever get the opportunity to just sit down and watch them, they're really good. Here's some shader optimization. Probably go through that once I start, getting some working with the GPU a little bit more. We have what's new in Metal. They're probably going to have a new one coming up fairly quickly. But yeah, they have sample code. So not all of these will work with OS X because unfortunately, OS X doesn't support a lot. Not a lot, but a couple of things such as. Well, let's go look at it. So if you go up here, you can see that this says the feature sets. So what does this mean? Well, the availability limits and pixel format capabilities of Metal feature sets. So by iOS 8, iOS 9, iOS 10, TV, OS X, Mac OS, what supports what? And you'll notice that OS 10 rocks the boat. There's only a few things it's actually missing, which is really cool. These two things don't even count. This border color and dual source blending. So you notice that it just has this cube Mac texture barriers layer. Like that's only a few things. But Mac OS looks like it comes in a close second. And that's because it's, it comes on every Mac. Every Mac can run Metal. Every newer Mac. I have a 2013 and it runs Metal. If you don't have a 2013, maybe it's I don't. That's I'm not gonna get into it. Anyway, SimDBare. Yeah. So there's some weird things, and I don't even know what these words mean. And anisotropy, anisotropy. So I guess we don't get that. So that's a bummer. But yeah, so the reason I'm doing Mac is because it supports a lot, and you don't have to have a device, and I don't have to show you my device, and I don't have to do any of that. It's just all on the computer, and we can learn how to do graphics programming together. A couple of these other things that were on here, though, I just want to show you. I'll probably reference them a lot. There's this best practices guide, so what. How to use stuff. So you wanna make these transient and not transient, meaning reuse them or don't reuse them, or build your pipelines once. There's that. Allocate up front. This will just kind of give you things that like Metal. The idea behind Metal is it's super optimized for Mac devices, and if you're using it improperly, then you're not getting everything out of it. And so that's what this site does. This documentation does. This right here goes over how the pipeline works. I'm going to go into this kind of often to look at these images because I like to reference them while I'm going through. What's this one? Right here. And then this is the metal shading language. So if you want types or how to declare things, you'll notice like these floats or positions. You know, you can have x equals position.xw equals float 2, even though there's an xyzw. There's four position.x these things. You can declare exactly which one. So this kind of goes through all the nifty quick ways to do things, so you don't have to do that. So yeah, I'm gonna jump right into it. That's just kind of the references I'll be using, but we're gonna do a Mac OS Cocoa application right on your desktop. Boom. Next, I'm gonna call this Tui Time Graphics. Why? Because I can, and because I'm Tui Time. Yep. So organization name is gonna be Tui Time. You do whatever you want on these. Really, this doesn't apply to everyone. Let's see, I'm getting a message. Oh boy. Okay, so that's kind of cool. Yeah. So we're not going to use core data right now. We are going to do unit tests maybe in the future. And yeah. Sorry it's taking me so long to get started. I should just get started and jump right into it. I know you're excited and I'm excited, and you clicked on this video because you want to get right into things. I want to make this as short as possible, so let's do this. I'm sorry. So we're gonna just make a new file in Documents. It's gonna create it there. This will start up. It'll do all of its stuff. Like I said, I have a 2013. It might take some time. I'm so sorry, but that's okay. I'm gonna open up GitHub Desktop. Oh man, that thunderstorm. And here's GitHub Desktop. It's free. Just go download it. It works. Since our Swift project made this in Git already, so we don't even need to worry about it. We can just go to choose from our choose from our local path, and then go to it in our documents, and then just add repository. And since it already applied Git, it will show us that these are all of our changes, which we didn't do anything. It was the initial commit. When it creates a project, it creates an initial commit. What's cool about this, if you don't know what source control is, it's basically so that if you mess something up, you can go back to the original version, or go back to the original code while you go back and fix the other code. So if I go here and I go swift.print hello Tui? I've got to spell it right? It's important. So I'm going to go right there, and like I press save and I go back to Tui Time Graphics. You notice that there's one uncommitted change, and it's swift.print hello Tui right there, and we can commit that down here easily by just saying added hello Tui, and then you can do a description if you want, but I'm not gonna. It'll commit. You'll notice we have all of the code from behind. So this was the first commit, and then I went in and added hello Tui. You can look through all the files. Here's all the files it changed. So the view controller, it added that. If I were to make see, it went from this to whatever was here. So yeah, that's how we're gonna use Git. I'm gonna use that after every major thing I do, I guess, such as start by creating a window and then go on from there. So yeah, all right, so let's start this off. I like to organize this stuff by creating a new group, calling it other. Oh, okay, I guess I don't want to call it other. Call it other, and then I'm gonna store all of this stuff in it because we're going to be referencing it. We are, however, it's it's all really important, but I just kind of want it hidden from our view, and so I'm even gonna put a Z at the front of this, like the, so that it just stays at the bottom. So I know where it is. I'll organize that a little bit later, but yeah. Next, we're gonna go to our main storyboard and talk about some stuff. So here's our main window, our view controller. This is where we kind of come in. We're gonna keep this the same. I like it. We are gonna change the size of this screen though. So if you come here, click on this screen, click on this guy, it's a little ruler, and then you go to width. I'm gonna make him width of 800 and then a height of 600. These aren't aspect ratios that are amazing, but their aspect ratios, and they'll work. So we'll have that. The next thing I'm going to do is I need to make this. Okay, so what you can do is so this is an NS view. This right here, if we were to go to here and click on this and click these little rings right here, this controller comes up. Cool, like that's awesome that it's attached to a controller automatically when you just do everything here. However, Metal has this really, really cool thing called the MTK view, and in one of these it talks about the MTK view and how you can make it a delegate, and instead of making this whole window an NS view controller, we can just make it an MTK view, like a MTK view. So I don't even need this view controller. So I'm just gonna get rid of it. I'm gonna delete this thing. So I'm gonna move to trash. Removing the reference, I think, keeps it there. It just removes the reference in this project. It keeps it there, but if I move it to trash, that goes away forever. And now it's all this stuff, which is just compiled nonsense that you don't need to worry about. It'll do this automatically. It looks like an auto file. But we will, however, need to tie this to a different window. And like I said, it's going to be an NS view. So let's go ahead and make a new file. Call it, it'll be a Cocoa class. We're going to call it main view, main window. How about metal view? Because that's what I've seen in a lot of the other places. They just call it metal view, and I kind of like that. It'll be an NS view. We don't want to create an XIB. Wait, NS view controller, I guess. We'll just go from NS view. Language will be Swift. Click next. TUI time graphics right here. Add it right there. I guess I shouldn't worry about that. And we have our metal view. Okay, so this is annoying. Look at that. That's annoying. But I think this will be the only view I make for a little while, so I'm not going to worry about it. I'm going to delete it. There's a really cool way to set your templates so they don't auto-generate that crap, and I'll show you that eventually. So here's our NS view. Don't need any of this. It's not going to be an NS view. We're not going to need that. We're going to import MetalKit. MetalKit has a lot of cool things attached to it, so you don't need to say import metal. Import like SimD, which is a math library. Import all these other little metal things that we need. MetalKit has a lot of stuff built in automatically, and like it has this MTK view. And yeah, so we're going to utilize that. We're just going to call this. So it's going to inherit MTK view. So metal view is MTK view, and here we're gonna just do an override in it. I think coder, right? Coder. Oh no, you know what? I'm sorry. I'm just gonna say init, and it should tell me some cool stuff. It'll say this guy required init. That's what I meant. And then we're gonna need to go super dot init coder. There, boom. And then one other function that this has is it automatically has the draw function. And I love how fast IntelliSense is. We'll just do this guy, delete him, just to make sure it works. Swift.print, hello TUI, this is where I'm gonna do it. This guy should go away, hopefully. Oh, override? Probably override. Yeah. So we got to override the function that this MetalKit view has. And now that that's set up, we need to attach it to our view. So if we go over here and we click this, okay, I've messed up with this so many times. I have no idea. It'll just fix itself if this doesn't work, but we can just go metal view. Hopefully, I'm gonna build. I clicked here and then I mean, sometimes there's errors. I probably should get rid of that Swift.print TUI. Oh my gosh, failed faster. See, so here's this unknown class stuff. It is using my view, but it's not using it correctly. You see, it's getting this main.story NS window controller stuff, and we want to make it so it works. So I'm just gonna fiddle around for a second because that's what usually ends up working for some odd reason. If you know what the hell the reason is, I would love to hear it. I'm going to try doing it to the top up there. This won't be all the time. It's just this one thing I struggle with, and I can't figure out why. I've Googled it a few times to even get that stupid error. I'm going to get rid of that Swift.print TUI just for now. And it looked like it threw the error, so I'm going to go here. It looks like it just came out. E-Time Graphics. It knows what I meant. It knows. This is called Metal View. Metal View. I'm also going to take you and put you outside. What are you doing? What are you doing there? Alright, I'm going to go to build, debug. I know there's a way to like clean, right? Let me see. Clean. Build. Alright, so let's try that. Let's run it like that. And nope, still didn't work. See, I don't know what it is. See, they'll get rid of it right there. I'm pretty sure I click out of this and I click in here and I say Metal View right there. Let's do a build, clean build, just for S's and G's. That shits and gigs if you were curious. S's and G's. Run it. Oh God, come on. Inherit from target. I'm gonna add it to both these guys. It'll go away. Don't get me wrong. You might want to fast. Oh, what is that? That's view controller. Maybe that Metal View scene. There it is. There it is. So maybe this doesn't need to be Metal View. I think that's what does need to be Metal View though. Yeah, because that's our view. This doesn't need to be Metal View for sure. I mean, I'll try it, but I'm pretty sure that this screen inside is. Oh boy. Oh boy. We're gonna be drawing graphics in no time. All right. Setter or instance variable. Unrecognized selector sense instance. All right. And I've tried Googling this. It doesn't usually come up with anything that I care about. So we're gonna do that. I'm gonna go here. I'm gonna go Metal View, and this is going to work. Oh, it works. Yes. So just fiddle with that. Click in, click out, get this thing to go, because I'm not gonna freaking dive into how the hell that just worked. It's so annoying. I'm sorry about that. Let's get coding. Okay, so now that we have a Metal View, we can call this draw function over and over and over and over and over again. But the issue with it, no, there's no issue. Okay, cool. We're gonna take this draw function out eventually and put it into a renderer class, because this is our view, not our renderer. We're going to be putting button clicks and all that sort of stuff if we wanted to in this. We're not going to be putting rendering stuff in here. So for now, we will make a renderer class just because that's what I want to do. So we need a renderer. That's it. Okay, so no, you know what? I'll show you what's up. All right, so this is NSView. NSView has a device, and what a device is, it's the very first starting point of the GPU. It is the GPU. It represents literally the GPU. And how this works is you have a device, and the device is used to, you kind of send these command and codes to it, and the device knows how to process that, parallelize it, and yeah, so we'll use the device to make our rendering pipelines, our depth buffers, our all that jazz. So let's get into it. All right, so the first thing we'll need to do is set the self.pixel format. So the pixel format equals .bgra. 8 unorm. So you see how this is the MTK view. MTK view is what we're going to be applying all of this stuff to. So MTK view is literally this is our MTK view. So that dot color pixel format is going to be .bgra8 self dot. We also need clear color. So clear color equals, and the clear color is going to be, so this is going to be flying. It's going to be doing 60 frames per second. It's going to be attempting to do 60 frames per second. And every second it's going to clear. And so this clear color is what it's clearing to. If you've done graphics programming before, some of the stuff I might say is redundant. Do your best to ignore it, but I'm going to say it anyway. So MTL clear color, you need to instantiate it, and then we'll do this red. And I'm going to do this 0.25. I like green a lot, so I'm going to go 0.57. I'm just making up numbers. Make up your own. If you like blue, do blue. 0.439. So I'm going to do, and then 1 for alpha, and then boom. And then we're going to want to go down and say, the next thing we're going to want to do, yeah, let's make our renderer. Self.color picture, self.clear color. I feel like I'm missing something. Self.blah, blah, blah. All right, I'll figure it out. It'll break. So we need a renderer class. So right now I want to just say renderer equals renderer. And then I want to, I know what I'm forgetting, because we're going to pass it in. First thing you need to do is what I was talking about before. Self.device equals MTL create system default device. And that's going to create the device for you. We're going to allocate this separate GPU. You only need to do that once at the very beginning, and then you don't need to do it again. It represents your GPU. And then we're going to pass in the device. And then I'm going to put the renderer up here. So var renderer, and then that's going to be a renderer. Doom. Okay. So everybody happy? No, because the file doesn't exist. Let's make the new file called renderer. It's going to be a Swift file. Oh, okay. Actually, so this is the beginning episode, so I can do this. This is okay. We're going to call this renderer, and I'm going to create it. And look, you might have got like Rick Tui, blah, 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 all this stuff created by on this date, whatever. No, I didn't. And why didn't I is because I set my templates. And I'm just going to show you the path to where you need to go to get it, because I've already done it. But it's super useful to know. So if you go to your Finder and you go to Applications and you go all the way down to your Xcode and you go to Show Package Contents, and then you go to Developer, something library, Xcode, yeah, templates, yep, file templates, and then you can go to Source. Yep, and see here's this Swift file.x template. This right here used to say all that stuff inside of it, but I edited it by opening it with TextEdit. One thing that might happen is it might have a permissions issue, so you'll have to go here to, you have to click on this, right click, go to Get Info, and this guy comes up, and then you'll need to go down here and do these read and writes for all of them by clicking this. So you'll click this, enter your password, and then you can set these to read and write. That's if you have admin privileges, and then it'll open in TextEdit. But you might actually have to do it on the parent folder, and sometimes even the parent folder. So do it on that file, this file to unlock it, and then you can change the template, and then you can make it look like this, so it doesn't just say all that stuff all the time, because I don't care what that stuff is. Okay, I'm gonna kind of make notes because there's some things that I want to look up that I haven't actually looked up. So I'm gonna take this, I'm gonna grab a pencil here because I have one so conveniently placed right in front of my face. All right, I'm gonna take some notes because there's some stuff I want to look up, such as why foundation. I'm not gonna look that up right now, but what is import foundation? I'm sure it's important. I've never actually looked it up, and I want to tell you what it is. So, look up. All right. Take notes for that later. Okay, so let's do this renderer class. Damn it, I thought that would work. Oh, it's because it's TUI time graphics. This should be maybe 3 other. I don't know. That's a stupid name. I'm just going to call it other and move everything. Okay. So right here, we're gonna get rid of this import foundation, import metal kit, and we're gonna make the class renderer. And if you guys want to let me know if I'm going too fast or too slow, let me know. I'll go faster and slower in the next videos. I'm going to push this and see what you guys think of all of it first so that I do it at your speed. I might do a couple of videos, but just let me know. Let me see. So our render is going to have an init. It's going to pass in the device, MTL device. Yeah. So that's our renderer. Okay, so the reason I created this renderer immediately and I didn't do any of the stuff for metal on this class is because we're going to use this renderer as the view delegate. So I'm going to delegate all of my view stuff to renderer. And that's really easy to do. You just have to call this an S object so it conforms to, you know, properties of the delegate, and then outside of the class all we have to do is call extension. This is an extension of renderer as a mtk view delegate. You see, there's a couple things that the view delegate needs, such as will resize, so func mtk view, that's the one. So drawable size will change. That's when you resize the screen, and we'll probably use that in the future to maintain an aspect ratio. And then func draw, I think, comes up. Yep. And so in view, we take in our view, and this view represents this view. So when I get rid of this draw function and underneath here say self.delegate equals renderer, it knows that it inherits that. Oh, it knows that it inherits that view delegate, or it has that view delegate extension, and it will use this draw, pass in this view, so we can use that view in here, so we can separate out functions that should be in the renderer into the renderer, and functions that should be in the like the view in the view. Device needs to be right there, and that should do it. So now if we build, nothing's gonna happen, but we know that everything succeeds properly. So look at that, all this is good. This is just giving us initialization successful, and we have our window. Yep, so we have our renderer now. Let's get to clearing this screen. Okay, getting more. Of course I would. All right, so the renderer. How to describe the renderer. All right, let's jump into here. Let's jump into here. What the hell are we gonna be doing? Is it right here? I think it's in this one. Yeah. So our renderer, oh, I'm so bad at explaining things, but I'm gonna try, and just bear with me, my friends. Okay, so here's our application. Okay, this image is so perfect. I love it. I love looking at this image while I code because it represents everything that we need to be doing. So I'm gonna make it a little smaller so we just focus not on any of the writing. Okay, so if we look at this image, here's our application. Our application needs a render pipeline descriptor, and what our render pipeline descriptor contains is all this stuff, and then it goes to compiler, cache, render pipeline state. So what where I'll start is at the end. So we need a render pipeline state in order to render anything. So keep that in mind. We're gonna start from here. Render pipeline state needs all of the stuff ahead of it in order to render. So we're gonna work backwards. This compiler cache is kind of automatic. Don't worry about that. Just know that we need the render pipeline state, and then inside of the render pipeline state, we need something that describes it. So we need this render pipeline descriptor. Descriptor goes into the state, and you can just say render. When you make the render pipeline state, you'll instantiate it with a render pipeline descriptor in the parameters. Like that's how it goes. And so you see how we have this vertex layout, this vertex function, fragment function, render pipeline attachment descriptor, depth, and stencil. All we care about right now to clear the screen is, well, none of it. To be perfectly honest, to clear the screen, we don't need any. We need some of this stuff, but it won't do anything. So I'll start from the beginning. We have the vertex layout. This is how, so in graphics programming, when you're passing data to the GPU, you're not necessarily passing, you don't just say, hey, draw this vertex. Know what a vertex is. Please, I need you to, no. You can pass in any kind of data you want, but you have to tell it what the hell the data is. And so what you do is you use this vertex layout to tell it what it is. So if you create like a struct called vertex, and you have a position, which is a float 3, and a color, which is float 4. You need to tell that the first thing is going to be a float 3 in the vertex layout. The second thing you're going to need is to tell it that it's going to have a float 4 as a color. And then once it goes to the GPU, it'll know how to dissect it and use, oh, okay, float 3, float 4, and separate it out. So that's what the vertex layout's for. Don't need it. That's what it is. Vertex function. The vertex function is what handles the vertices and plotting them in space, in three-dimensional space. I'll get into that when we get to drawing vertices, probably within this episode. We'll just draw simple vertices, and then that might be it, because I'll need to get off soon. That storm looks pretty bad. Fragment function. The fragment's going to be pixels. So what happens is it goes from the vertex function into what's not pictured here, the rasterizer, because we can't control the rasterizer. The rasterizer does its job like it should, and it turns all the pixels inside this primitive. So you have a triangle, and inside there's a bunch of pixels in there. There's 3 points, so every vertex needs pixels that associate with it. So this top little portion of the triangle up top will be what it designates for this vertex. It'll designate for this vertex, designate this one in the rasterizer, and then when it outputs from the rasterizer, we'll have pixel positions, and we can color those pixels in the fragment function. So we'll be able to write the vertex function and the fragment function to do whatever we want. The render pipeline attachment descriptors. Basically, this is what it's kind of okay. So we have our MTK view, right? And the MTK view has color pixel format. The render pipeline attachment descriptor will have a color pixel format because it needs to know what that is. So we'll put stuff like that in there. The depth attachment and the stencil, those are for depth, so three-dimensional stuff. We won't get into that for a little while. And then just know that's all in the render pipeline descriptor. Now we take this render pipeline descriptor and we shove it in the app. We shove it right up the app. So we'll need all of this stuff to go into this render pipeline state in order to just clear the screen, and to draw stuff on the screen. So let's do this. Let's start this, okay? So we need to make a render pipeline state. I'm going to put this down here in the bottom left corner because that's a good spot for it. And then I'm going to come here and attach you to the side window over here so that everyone can still see it. Go right here. I don't need you anymore. And yeah, let's get started. So we need first, like I said, we need a render pipeline state. So let's look at that image and we see that. So we need a var render pipeline state. The render pipeline state is something we will only create one time. Okay, we don't want to keep remaking render pipeline states. However, you might need a render pipeline state for multiple like vertex and fragment functions and different things that you do. So if you're drawing textures, you'll need, or if you're adding textures to objects, you'll want to have some sort of a render pipeline state for that. And if you're just drawing a triangle with normal pixels that you're not texturing, you'll just use a basic one. So that does depend, but don't recreate the render pipeline state if you don't have to. So let's do that. So let's go here. We're going to go and say build. Well, we're going to have to call self.init because it'll complain. And then we're going to make a function called build pipeline state right there. And then we're going to pass in the device. We could make the device global. I don't want to because I like the way this looks up top. If we have to in the future, I will. Func build pipeline state. and then pass in the device as an MTL device. If you're curious as to how Swift works and like what, like the syntax and what I'm typing and what that means, I'd be happy to describe it in the future episodes. Just let me know. I do not mind. Self.init. What are you doing, dude? That's not right. What are you doing? Did you mean build pipeline state? Pipeline state. That's not what I meant. I meant this. Give me 1 second. Oh my god. IntelliSense. You're drunk. What is this? I don't think I need to do that. It wants me to do this convenience method, but I'm not gonna do a convenience method. You can't make me do a convenience. So you're good? Oh, God. Are you good or are you not? All right. So I know for a fact that I don't know for a fact. Give me a second. I'm gonna try this, and I'm gonna say. See if it stops complaining. Oh, self.init. What does that mean? I know what it is. Sorry, guys. Act like you've done this before, dude. Super.init. We need the super class because we're inheriting from NSObject. And everybody's happy. Okay, so we're going to build a pipeline state right here. And we're going to need to create this render pipeline descriptor. So all of this stuff down here, well, not all of it. Ignore the vertex layout. We're not going to get there for a little while. The two we need right now is the vertex function and the fragment function. So let's go into the vertex function and fragment function. In order to create this vertex function, this fragment function, we're going to need what's called a library. And the library will make functions for us. So that's the first thing I'm going to do because we're going to need to make this render pipeline descriptor. But we're going to need to put these libraries in it, or these functions in it. So let's go var library equals device dot new default library. So that's just going to create a library for us. How nice is that? Now with this library, like I said, we're going to create vertex functions and fragment functions. So we're going to call var vertex function. We need to create the vertex function equals library dot make function. Look at that. Just that's as simple as it is. Make function. And then don't pass anything yet because we're not going to worry about that yet. Var fragment function equals library dot make function. Boom. So you notice that we have these empty strings right here, and that's because the vertex function and the fragment function, these are literally referring to our metal shader file, which is what kind of makes the metal. That is what the metal shading language is. This is all Swift. The metal shading language is using metal files, which is more of a C language. But we're not going to create that yet. We are going to name these functions right here. I'm just going to call this base. No, I'm not going to name them yet. I'm gonna just do that. So we have this vertex function and this fragment function, and they're going to be referenced by this file right here. So we're going to make this metal file. We're going to use this metal file right here. This metal file will be where we do the C-type programming. We're going to call it shaders. Shaders. Yeah. And then we have the shaders right here pop up. Oh man, I need to template that. And yes, this is our shader file. You see, this doesn't look like normal Swift. It's because it's not. We're just going to create the most basic shader you could possibly create because we can't clear the screen without having a shader. We can't use metal without metal. You know, it doesn't make any sense. And so we need metal. Let's do that. So, like I said, you need a vertex function and a fragment function. Okay. I'm going to draw it out just a little bit better for you in what the hell is going on with this vertex function and fragment function, just to make it more clear. And I'm going to start by drawing this right here. What are you doing? Yep. I'm going to do an arrow with this, I think. Yep. Boom. right there. I'm going to copy that and paste it because I'm going to need one more. Right there, and then, oh, I don't know what that was. Screw it, I'll just draw one. Right there, and then we're gonna go here, and we're just gonna, sorry, this looks bad. Maybe I'll get a pen or something to draw with so it's easier to see what's going on. So this right here is going to be our vertex function. And we're also going to do one more thing. I'm sorry. We're going to come right here. And we're going to pass in data. Data. However the hell you want to format that data is your call. I'm not going to tell you what to do. I can show you how I format my data, which is how I've seen a bunch of people format the data. I'm sure it's all the way around, or like global. So we got fragment function. No, this isn't fragment. This is the rasterizer. So this goes in the rasterizer, and then right here we have the fragment function. Okay, so you never need to call the fragment function. It's automatically called once you return whatever data from the vertex function. It will go into this rasterizer automatically. This doesn't really even exist. This rasterizer doesn't exist in your eyes because it does it manually or automatically, not manually. Sorry, I can't talk. I'm gonna do this. So our vertex function will pass into the rasterizer. The vertex function will plot the points. So this will draw our triangle however we want. So we have a triangle with 3 vertices, 1 vertice, 2 vertices, 3 vertices. The vertex function says, okay, well, I know that there is a vertice right here, here, and here. And it will say, okay, well, there's this, and then it'll kind of connect, but not really, not yet. It will just draw this kind of more of a dotted line. Don't think of a straight line yet, because it's not really a line it's drawing, because we're not drawing lines, we're drawing a primitive called triangle, and I'll get into that a little bit later. But this right here gets passed into the rasterizer. The rasterizer takes this image. Oh boy, wish I had this like down there. Let me see if I can suck this up, because I would like to. Yes, cool. I'm gonna take you, put you down here. Oh, I don't know if you can hear that thunder, but that sounds awesome. So we're gonna copy, paste, put you back, because that makes sense. All right, so we have that. It goes into here and it says, all right, so I'm this vertex and I am, gosh darn it, sorry. I'm gonna color these red, green, and blue. So you make a well, I'm gonna copy this. Paste it right there. So it just plots these vertices. It goes in here and it says, okay, well, I know that you have these, I know that you have pixels. So what I'm going to do is I'm going to find out this vertice in relation to these vertices, and I'm going to give it a pixel and a pixel. And it just kind of plots all the pixels. Just for this one vertice, it's going to plot these ones. For this vertice, it's going to plot these ones. They're going to connect because it knows that it connects via lines. See that? And then it'll take this vertex and it'll create all of these right here. And then, so once all these pixels are drawn, without color, there's no pixels here. It's just kind of figuring out what the pixels are and where they should be located. It'll go here and take this guy and put him into here, and it'll say, okay, out from the vertex, we pass out from the vertex function data that has a color attached to it. So remember, we have to describe what the data is. We're going to describe color. It's going to take this color and it's going to say, okay, well, we have pixels right here. We have empty pixels. What color is this? Oh, well, it's green. So we're going to put green right here. This is all, or green, God, red. This is all red right here. And then it's going to look at the next one and say, okay, these are all green. These are all green right here. These are all green. We have pixels to fill in. It's going to go to blue, and it's going to say, okay, we have pixels to fill in. We have pixels to fill in. And then look, so there's like this space in the middle. And so what this rasterizer also does is it computes the interpolation. So say this is red and this is blue, or any color, and this is a color, and it just kind of figures out these values right here. Well, it'll kind of draw some red right here and some blue over here. Oh, because it's going to interpolate these together and create like a purplish color, more so because it'll combine them. And then it'll do the same with the red and the green. It'll draw some green over here, some red over here, and then it'll combine those together to make its own color. And then it will combine the green from here and kind of come over here a little bit, and then this would come over here, and it just interpolates these values over here, and then this just fills in these pixels. So say I'm computing shade, well, I can pass in exactly what, so I can pass in this point right here as the main point. I'm getting a call. Okay, I'm gonna pause just to take this call, and then I'll get right back at it. That was a loud thunderstrike. Thunderstrike, that makes sense. All right, so where was it? Interpolation. So we have red, green, blue, and then it would combine all those colors together, and it does that. So that's what our fragment function will do. And if we had shade, and this point was our intensity, so say right here was our light. Well, we can kind of divide by whatever and make it so it goes a little bit darker, so that this is the main point, but this would be darker than that, so it would act just like light does. So here in the fragment function, we do that. We might actually do that, some of that in the vertex function, but we shall see. We'll probably do a lot of that in the vertex function. The fragment function, just draw the color. It doesn't matter right now. We'll get into it. Fun stuff. All right, so that's how the vertex, the rasterizer, and the fragment function works. Let's do them. Let's do the most basic of basic. Basic. So in order to declare a vertex function, we need just to put vertex. If we were doing fragment, we'd put fragment. But since we're doing a vertex, we're going to do vertex. And it acts just like a C function. So if you know C, you're 10 steps ahead of the game. We're going to return a float. A position is 4. Float 4 looks kind of like this. So X, Y, Z, W. And that fourth component is so that we can do three-dimensional graphics and do 4x4 matrices. We'll get into that more in the future. So this will return a float 4, excuse me. Position. This will just be a position to start out with, and then we will just call it basic vertex function. So this is the name of the vertex function. Won't pass in any parameters yet, and then we will return a float 4. Gosh, I can't type. 4, and we'll have 1. So that's the same as saying float 4 1 1 1 1. So the position will be at all 1, X, Y, Z, 1 1 1 1. So this is the same as what we're returning. Next, we're going to do the same exact thing for the fragment function, except we're going to replace all the vertex. We're going to declare it a fragment function. You can even do like compute, compare. There's a couple other different things you can do. You can like compute math and stuff on here a little bit faster. We're not going to do any of that for a little while because I don't know how to do it, to be honest. I haven't dove into that aspect. Might do it on here when it gets experimental. But so here's basic fragment function and fragment. So now we have a basic fragment function, basic vertex function. I'm going to take this name, go to my renderer. I'm going to put it right here because this is our basic vertex function. This name needs to match it. And now it knows, it's smart enough. Oh, these should be lets. All of these should be lets because we're not actually going to change them. They're not. Oh, geez. Ledger. That's what I meant. Heath Ledger. RIP. So we have basic vertex function for the vertex function, and then we need the basic fragment function. Actually, you know what? I'm going to go and just copy it just to make sure. this name needs to be exactly what this is, because it will go through your file upon compilation. It will go through your file structure, find these shaders, compile these functions down, and then it will search kind of like a dictionary for this name. And if you have the key, the function would be the value, and it will find it and use it automatically. You don't need to specify any file path. It's kind of nice. So it'll do all that work for you. Now, moving on. Now that we have our vertex function and our fragment function, we will need to go down here and put these in our render pipeline state. So we know we have our vertex function and our fragment function. That's all we need to draw to clear the screen. And maybe a little bit of this guy, but don't worry about that yet. We need to go and make our render pipeline descriptor to store into our render pipeline state. So we're gonna just say let render pipeline descriptor equal mtl render pipeline descriptor. Boom. That's it. When you're creating these, you don't need to call device.make this. It just we just call the constructor because we don't need the device for it. For the render pipeline descriptor, we will need to set the color attachments at 0 position to pixel format equal to exactly what the view was, which was .bgra 8 unorm. And this is just a format of storing pixels, like a way of storing pixels. You can have like BGRA, I don't know, there's a bunch of different ones. A unorm, there's this way, so there's like green, blue, green, red, I don't know. So there's just a bunch of different ways. This is the most common way to do it. We might get into that later too, because I'm actually curious about it. And then we're gonna wanna set for the pipeline descriptor dot, well, look, we got our vertex function. In here, we're going to set the vertex function equals vertex function. Simple enough. Render pipeline descriptor dot fragment function equals fragment function. And yeah, that's all we need for the clear screen. We'll probably need to set this vertex layout too, and then the render pipeline attachment descriptor, the depth, the stencil. We'll have to do all that, but we're not going to do it yet because we don't need it to clear the screen. All I want to do is clear the screen. So actually, I think I read this as we were coding. Let me open up Hue. I know we were looking at that picture, but I think best practices guide. Let me see. So this says initialize and your command queue first, and we didn't do that. We should do that. Let's do our command queue. And what our command queue is something else. I'm gonna kind of stay on track. I'm sorry, I'm getting off topic just a little bit, but we'll get back to it. You don't necessarily need to do it for, as long as it's a part of one of the first things you do. I think that's what's important. So let's get back to this guy. Go back here. So now we can say do. It's gonna be a do. We got to try this. This is got to be a try catch. Do, and then we're gonna say render pipeline state. So let's create this render pipeline state equals try device dot make render pipeline state. And you see we pass in the descriptor. It just has a descriptor. So render pipeline descriptor. You see, we put this descriptor inside of this render pipeline state, and now we can use the render pipeline state. Okay. And then since we try, we're going to need to catch it, and the good way to do this would be just be catch let error. So we're going to define error as ns error, and then we're just going to swift.print. That's not a function. Print is a function. And then we're just going to go error. So that'll give us our error if the render pipeline fails to be created at some point during the application process. And beautiful, we have our function, we have our pipeline state. The next thing we're going to want to do is, like I said, command queue, and we can even do that first. So let's do that first. So func command build command queue. I'll get into what the command queue is in just a second. Build command queue. And we're just gonna call this guy, we'll call him first. That's what it says. Do your device and do your command queue first. And we already did the device where we said device dot equals new mtl dot create new default device in the view. So we've done that. Now we're doing the command queue. Then we're gonna build our pipeline state. Okay, so the command queue. Another thing that we should only create once. Var, I'm gonna put it first. Var command queue. MTL command queue. This is what's in charge of pushing and popping our view. So if we want to render this drawable and then this drawable, then this drawable, this will be in charge of putting things in front of each other. Once we get into exactly what's happening, I know you graphics people who already know this stuff, like what the hell FPS means and why it's important, but you know, the game loop's actually a really fundamental part that you need to understand. So I might jump into exactly how that works. But the command queue is basically in charge of pushing those drawables and pushing everything onto the view. And so let's create the command queue, which is easy. It's one line of code, and it's command queue equals device dot make command. Oh, well, we don't have a device, do we? Build command queue. We need to take in the device. I'm just gonna copy because I'm lazy. Right there. Boom. Boom. See, we don't need a global device if we just do it this way. And then we can go command queue equals device dot make command dot. What's going on here? Tell us sense. Wake up, dude. Dude. Command queue. Couldn't remember what it was called. I thought it was that. But so look at that. That's our. This is gonna need to be that, I think. So this is how we're gonna build our command. Oh, you don't need it. Oh, because it's a freaking parameter. Nice. Okay. So that takes that. That takes that. We're gonna build our pipeline state. Now we have our render pipeline state, so we can draw this screen. There's nothing else we need to do. We built our command queue, simple. We did our render pipeline state like it wants, and now that we have that, we can draw things. There's nothing else that we need to do to draw right now, at least. So let's do this. So draw will be okay. So we're going to need 1, a current drawable, 2, a render pass descriptor. The drawable is going to be us asking the view for a drawable to draw. We're going to say, give me the next available drawable. Like, you have one, I want it, I'm going to draw it, so let me have it. And it takes it, and it pushes stuff onto it, and then it pushes it back out. So that's what the current drawable is. The render pass descriptor is like the descriptor that describes what's going to happen. I think you can have multiple render passes. I haven't actually done that yet. I know that you can have like a render pass for shadows, and you can have a render pass for, I don't know, lighting and stuff like that. I haven't actually got into that personally in my own development, so that might be a little experimental. But once we get into it, it should be pretty fun, I would assume. And I won't just jump on here without knowing something. I will practice it before I do this, so you're not just seeing me say, "What the fuck? Okay, just research." No, you don't want to watch me research. You want to see. So this will force me to learn, and it'll force me to teach you well, because I don't want to talk like I'm an idiot. I do not want to do that. So let's draw. So the first thing we're going to need is that drawable. So I'm going to call this just drawable. Simple. Equal. Well, we're going to guard this so it doesn't break when it's like, give me the drawable. And it's like, no, F you. And then it doesn't. So let drawable equal, and then we have our view. So current drawable. It's going to say, please give me your drawable. It's going to give it to it. And then we're also going to say let render pass descriptor, like I said, equal view.current render pass descriptor. And then we're going to say else. If you don't like that, please just return. Don't cause a fuss. Just return. Okay? It's probably broken. Just return. All right, so that's going to work just fine. Once IntelliSense is like, dude, wait for it. Dude, what's going on here? Why are you? Oh, because I put let. Is that what you're yelling at? No, I need let there. What are you doing? Okay. IntelliSense just gets me all the time. Love-hate relationships. So now that we have our drawable and our render pass descriptor, we can create a couple of things. Now, this needs more explanation. Can't. One does not simply just render things. This beautiful image. Okay, so we created a command queue, and I didn't really go into it in detail, but this is what the command queue represents. Right there. Okay. Okie dokie. So we have our command queue, right? We already made that. We already made our command queue. Now, just like I said, we're going to start from the bottom and work our way up because we need to store things in the bottom. Like we need to... Whoa. Yeah, that was awesome. Okay, that's so distracting. Oh, it gives me chills. Okay, so the reason I'm saying we start from the bottom is because, say, I want to take this pen, and I want to combine it with, like, I don't really have anything on my desk with this coaster, and I want to squish it up. Like all this stuff is getting squished up and put into the command queue, but I don't have a command queue yet to store it into. I need the storage device before I should start. Because if I just crush this all up and I go to put it, I need to set it aside and then do it. No, first thing we need to do is, like we did, create the command queue. The next thing we're going to do is the command buffer. And then we're going to do a command encoder. And then, so basically that's why you kind of, on these diagrams, you want to start from the bottom. It took me a second to figure that out, but you want to start from the bottom because we need a container to put everything in. So this might look like a lot, and it is a lot. There's a lot of weird things to look at, and there's also more over here, but don't worry about that. Our command queue will have command buffers, and the queue, so these are the command buffers. Put the command buffer right there, put another command buffer right there, put another command buffer right there. And like we said before, the GPU is good at parallelism. And what the command queue will do is it will push this one, pop it, push this one, pop it, push this one, pop it, and it'll do that. So once we create this thing with all of our data and all of our vertex data stuff that we want to put into it, we can store it in this command encoder, push it into the command queue, and then the command queue will throw it into the it'll go through all the process. The command queue will basically display it. The command buffer is used to like present stuff. The command encoder, this render command encoder is for like the vertex data and the like constants data. Here's our render pipeline state, which we're going to store into it. Remember, we're starting in this way. We kind of started from render pipeline state, but then we're going to have our depth stencil state, or sampler state, texture buffer. But basically, all this stuff gets stored into our render command encoder and then our render command buffer. So let's do that. I'll follow this diagram just to show you because it's cool to reference. They put these things together for a reason. So we have a command queue. Perfect. Now we need a command buffer. So we're going to say let command buffer equal device. We have a command queue dot make command buffer, just like that. So now our command queue is going to make a new command buffer to push and pop. It's going to do that. Now we're going to need a command encoder. See, we have a command buffer, but we need the encoder, right? So let command encoder equal command buffer dot make render command encoder. Now this descriptor is the render pass descriptor for the view. Boom. See? This is why we need all this stuff. So our command buffer gets the render command encoder, and now our command encoder's job is to take all of this buffer data, this texture data, squeeze it all together, go into the GPU, say do stuff in the GPU, and then when I get it back, I'm gonna pop it, but I won't pop it until it's back. I need to get it back, and I won't display it until then. That's why it'll run this in parallel. You see, like if you go, I can't scroll because it's not displaying, but if you see over here, we have multiple command buffers being stored, and these command buffers will all have data, and they will push this command buffer first, and then this command buffer into this and this. So this is where all the parallelism kind of comes into play. So now that we have our command encoder, we can say command encoder dot set render pipeline state. Look at that. Storing our render pipeline state that has all this stuff. God, I'm getting calls. Render pipeline state into our render pipeline state. And I'm going to pause real quick, take another call. I'm so sorry. Okay, so I'm back at it again. Here we go. So where was I? Oh yeah, so we like it right here. We have render pipeline state, and we set the render pipeline state to the render pipeline state, which up here, we're going to add all of this stuff into here, and we are good to go. Now that all the command encoder is all ready to go, now right here, I'm just going to comment because we're not going to do it, but this is where we do command encoder shit. Encoder stuff. I won't swear, right? Because it's not, don't swear. And then after we're done with that command encoder stuff, which is applying our data, our vertices, our colors, our textures, all that stuff, we're going to just say command encoder. We're going to tell it that we're done. So we're going to just call it .end encoding. So we're done. Once we're done encoding and putting all that together, we are going to use our command buffer .present. And it's going to present our drawable. So we're done encoding. Now I can present the drawable because I took this drawable and I put it, I can present the next drawable, you see? So present the next drawable, since we set the, we use this command buffer to make this command encoder, all of this drawable will be, or this command buffer will be inside, or this command encoder will be inside the command buffer, and the command buffer knows what the command encoder is, and so it will use whatever the command encoder did to present the drawable with. You see that? That's kind of how that works. And then the command buffer dot commit. And once it's committed, it is going out to that screen. Commit, I'm pretty sure commit means show me to people. You know, if you didn't call commit, it wouldn't like this says present the drawable, but commit means I'm committed into this queue right here, and I'm ready to pop. But until you press commit, it's just like, all right, dude, I'm ready. I'm ready to present. I'm ready. Why is it, what the hell? Okay. All right. Whatever that means. So yeah. So now we're going to go here. We're going to press play because I think that's it. If everything works, we can just press play and we should get a green screen. First try. Yeah. Don't forget any of that stuff. Get it up here, eh? So yeah, now we have this really cool green window showing up. This is actually fantastic because now we can start putting stuff on it. But we're clearing 60 times per second. We're gonna want to. I kind of want to draw a triangle. You guys want to draw a triangle? How much time am I at? What does this say? An hour and 8 minutes. We're clearing the screen. We're ready to draw triangles. I don't want the upload to take like 40 million hours. And so what I'm going to do is I'm going to stop it right here and say, do you have any questions? Nobody? Okay, so this is easy. Okay, yeah, sure. You never have questions until you get home and you start working with it. So yeah, my recommendation for this is to I know this really well because I've done it a lot and I've practiced it a lot, and I've so I just say repetition is important. So repeat, rinse, repeat, and you'll get it. So this says window. That looks ridiculous. So I'm gonna go to my metal view. No, I'm not gonna do that. I'm gonna go to my main storyboard and I'm going to make this window not titled that crap. It says window. I think it's this. And I'm gonna call it Tui Time Graphics, son. Okay. See all these cool things too. We're not gonna get into that yet. This isn't a UI tutorial. This is a metal tutorial. We might actually do that. I might want to add some buttons on here so that we can, instead of using the keys, we can use a button and maybe adjust a slider to change the color or the shade or something, because that's kind of cool. We'll do that in the future. We can extract what we've done here real easily and put it into a window. NS. Is it just called a view controller? Custom. No, it's called a custom view. We can take a custom view and take that custom view and turn it into whatever view. So we can draw this multiple times on multiple windows. I think all we would really need to do is just take this custom view here, and you don't have to do this, but metal view, and if I press play, this will say, oh, I know what to do, and it won't be a window in front of it. It will be green, and we can't really see that yet. It might be on there, it might not be, but I'm pretty sure that once we have a triangle or something drawing, that will kind of replicate exactly what we're doing in our view. So yeah, save this. All right, so save it. I'm gonna run it one more time. Build it, I guess, mainly. That's all I want to do. And X that. I'm gonna put this down so I can open up the GitHub. Oh, sometimes it doesn't stop, so hello Tui. We have 5 uncommitted changes. See, we've added this renderer class, the shaders class. These are all our changes that we made. This is just kind of the project. The project changes based on what we do to it, so we won't see this one for a little while because I'm not going to do anything to the main project file. You see how it changes view controller into a metal view, and then it added these guys. So these won't change too much. It might change. I don't think it changes when we do when we add like renderer. Like if I search this for renderer, I can't search. That's pretty cool. But I don't see renderer. Oh, there. So it might actually do it for every file that you add. But that's what that folder is. This is the storyboard backend. This is an arrow. That's interesting. Must be like I converted it into this or something. But yeah, so these are our changes. It's simple. Now we can just say clearing the screen. Commit to master. History, it'll pop up over here as clearing the screen, and there's all our changes. So when you see it, you'll see this. Beautiful stuff. That's about it. Sorry. That's how I'm gonna start doing it. I know I'm gonna try to cut it off at like an hour and a half. But you know what? Fuck it. I'm gonna go. Sorry. I'm gonna try not to swear, but we're gonna draw vertices. Yeah, it was a good thing we stopped though. It was a good thing we did that. No, sorry, I'm conflicted. I'm gonna stop it. We've cleared the screen. We'll do clearing vertices. We'll do vertices in the next one. We're kind of set up to go, so I won't be regulated by time. I want to give myself somewhat of a time limit, but yeah. So that's it. Let me know if you have any questions. Hit me up in the comments. I'm gonna probably push this either tonight or tomorrow, and yeah, that's about it. So I'll see you when I see you.